So welcome everyone in the post-COVID times of teaching with new technology and new room, which is really spennende, we would say in Iceland. Glad to see so many of you here. Basically, the campus is back to real life. I see many familiar faces from other courses already, so I think many of you know my teaching style a little bit. But today is really more a kind of clarifying lecture, so we don't go really into content yet. Basically, it's really just thinking about what is the course organization, what can we do in order to find groups, what is about assignments, what about exams, and all these questions you probably have. So my suggestion is usually for the first prologue lecture, wait with questions. I learned over the last 10 years teaching that these questions will come up, and usually I address them as part of this basically part here in the prologue. Welcome everyone. I hear already Groska is not easy to find, so I hope you had a good chance to finding it. I got some questions already, but it seems like more and more make it. That's good. Excellent. Good. Yeah, you see lots of logos. I come to them also after another basically time, step by step. They fund a lot of activities we do, fund a lot of students I have. My research group is around 14 people right now. So, and all these logos are in one way or another basically contributing to our money in the faculty. And basically also we use this course here often as an outreach, as teaching also in these research projects that you see there over there. Coming basically a little bit to the course itself, which probably is of interest to you. I mean, many have seen already, you have the outline basically like we did the last couple of years. Obviously here and there we'll do some updates and tweaks, things like Docker, for instance, and Singularity. There have been some movements going to Aptainer, another container technology, which is the same with Singularity, some details here and there. But the big modus operandi of this course will be basically very similar like the one you see on YouTube. So if you're curious to see what's coming up, especially as you are still doing your baby steps of thinking, should I do this course or not? You can basically sneak a little bit into the next lectures already on YouTube if you like. Also, all what we do here will be recorded on YouTube. Basically, we will do practical lectures where I will show and demonstrate you a couple of things. This will be all uploaded to YouTube. So if you can't make it to the university, no problem at all, right? Everything is online anyway for the community. Now, when it comes to the outline of the course, we learned from the past 10 years teaching it to put lots of practical things in the beginning. You see here the green topics, which really are practical topics where assignments are basically considered for it. We do this very early on so that I can hand out to you the assignments as early as I can. Still, of course, here and there, you have some practical topics that needs to be underpinned somehow by more theoretical, conceptual lectures. Of course, we start basically with cloud computing and big data introduction here, but then really dive already in one of the key aspects where clouds are used with Apache Spark applications. It's not clear what that means to you probably, but we will see how that materializes when we have these lectures. Who of you used machine learning before? Deep learning? Machine learning, deep learning, okay, many of you, that's great. We will have some basics there as well, starting with a very, let's say, shallow introduction, very much assuming no basics, really, no big linear algebra when we start there, and then quickly make the move to the clouds in the first part. And then we learn a little bit about virtualization, data center design, so how we go bigger, bolder, and bigger data centers. We hopefully will also watch one, which is about Borealis data center. It's one of my project partners where we create a Reykjavik Institute, a new big computational facility here in Iceland. And our plan is to go also there inside a data center so that you can touch metal, right? So that you see data centers, not just a cloud. It's actually very physical and underpinned by high performance computing. Then we come to the second part here. You see MapReduce. Someone heard from MapReduce maybe before? Okay, a few. So it's a kind of computing paradigm which is often in clouds striving, so to speak, for high throughput computing. So it's not directly high performance computing, cutting edge computing in terms of capacity of the processing speed. Here we'd rather talk about big data, which is the other aspect of the course, to really process this in parallel, and then with a high throughput. And that is where clouds are very good in. And we will talk about this and learn about the MapReduce paradigm there. Before we then go to one of the major applications today in clouds, which is deep learning. Some of you already heard that, I guess, also from other courses. And we'll there learn a little bit more based on the basics we learn on machine learning, then what is deep learning, and so forth. So this is not a deep learning course, so right? So what you learn here is, let's say, a moderate introduction. If you really want to do cutting edge deep learning like we do in research or other areas, Magnus, for instance, and other faculties have a real good deep learning course to go to. Still, it's enough to apply it in cloud computing. And of course, there are lots of, let's say, learning advantages already, knowing already how deep learning is here from this kind of introduction when you then want to do subsequent studies in machine learning and deep learning. What I also would like to encourage you, it's a big, interesting field. There are lots of experts missing everywhere in the world. So it's a big job opportunity, which is, of course, one of my jobs here, to teach you something where lots of jobs are, not within Iceland only, also internationally. Then these are the two first assignments, basically. And what we then will basically dive in is a little bit more conceptual again, while you work a little bit on the assignments. This infrastructure as a service, platform as a service, and software as a service. Someone has heard about that, maybe. It's also common cloud paradigms. We have to admit, however, today, it's a little bit mixed, right? So in a way, you cannot make really a clear boundary between the providers anymore. It's really a big mesh, and we will talk about it. Still, conceptually, they play all a role on another level, basically. And we will talk about this. Before we come to the last idea of the assignment, where we talk a little bit more about big data mining, so recommender engines and association rules, frequent pattern analysis in big data, which then complements, again, the machine learning part with more data-oriented topics. Then in 13 and 14, we will skip the view a little bit more, again, to conceptual aspects. OpenStack is a cloud operating system. We switch the view in the sense of saying, if your boss comes to your door and say, we want a cloud in my own organization, what I have to do, right? You don't trust Amazon, you don't trust MS Azure because you have medical data or whatever. So you use OpenStack to create your own cloud, and we will talk about this. There are lots of open source material already there where you can build a cloud very quickly from scratch within an organization, still being actually interoperable with Amazon, with MS Azure, and so on. Then towards the end of the course, it's really more looking into Facebook. Obviously, Facebook and other online social networking companies are the players of big data, right? They have billions of customers and so many accounts and big data and topics and messages, etc. That it's quite interesting to see how they handle that topic. Of course, many of these things are closed source, so we cannot look into everything. But Facebook has also some openings in some of their software, how you understand that everything is a bit more graph-based and so on, before we dive then into big data streaming, which is still a little bit research, with the idea that maybe you don't want to keep everything which comes from the big data stream. Maybe you want to filter certain parts of it. Think about Twitter. When you have Twitter tweets, there's a big stream, tweets every little second. You as a company owners are not interested in all of that. You maybe just want to have a sentiment analysis. Is my product good in Twitter or not? So you need to filter this big data streaming coming in, and we will talk about there some applications. Welcome, everyone. Quite full room. It's interesting to see after COVID now. Good. Just a quick check to the online audience. You can hear me also well, and welcome of you to you as well, of course. Could you say maybe quickly in the chat that you can hear me? Let's see how that works. Sound is good. Perfect. Good. Excellent. Right. So much for the outline of the course. Let's come a little bit to the motivation and, the information, I think, things you're waiting for. It's really something we call between distributed computing and parallel processing, a topic, cloud computing, which is very hard to maybe define really, because it has so many facets, it has so many levels. But you would say it emerged out of these paradigms from distributed computing and parallel processing, which is more high performance computing. But still, clouds today really have this comprehensive approach of just swiping your credit card, and then you have lots of services. So this term services will be something you really are familiar with if you end the course. You will also know who was in my HPC course again. So I know some of you are, yeah. I think we have a couple of them here. Basically, it's a complementary course where, of course, many of the cloud resources in terms of computing capacity, storage capacity are high performance computers. They're just differently basically accessed via cloud paradigm. And we will talk about this. And whenever I say computing, this course also addresses the storage, right? Because this is something which by far today is our bigger problem, right? Computing is solved, so to speak. We have GPUs, tons of it. Now the problem is how we get all the data to all these GPUs, right? So this is a bottleneck we have in research these days, that basically the storage is a problem, not the computing. And essentially, we have a mix in the course, which brings you to really cutting-edge technologies, GPUs, A100s, but also think about the new cards that basically are not anymore NVIDIA in this course. There will be some news here in the lecture. This is basically a quite interesting field. But then also, of course, understanding the difference, GPUs, I think some make a question mark in their eyes. So what is a GPU versus a CPU? We will talk about this little by little. And then, of course, I think it's very important that you get some applications out of this, right? That's why we focus on machine learning, on deep learning, which maybe by far now are the most lucrative ones. There are very special ones in engineering we will talk about in Cloud, for instance, for computational fluid dynamics, for physics problems, so to speak, based on known physical laws, based on numerical methods. So, but this is something where it's rather niche market. And at the end, a little bit also from research. So what we're doing in research about cloud computing is this European Open Science Cloud you will hear a little bit about. So coming to the next topic, the idea what you should understand then is really how you kind of blend these two topics, parallel processing on the one hand, but then also in a distributed computing fashion. So what we did in HPC, programming MPI and things massively parallel will not be happening here. So here we do rather walkthroughs in the clouds and using these services. Still, I think it's good to understand that machine learning and deep learning really, is really powered by cloud computing and HPC today. So if you really want to do cutting edge learning by data or of data, you need to have these resources. Alone, if it is for hyperparameter optimization, we will have one of my PhDs talking about this. He is an ex-specialist in RayTune. So we talk a little bit about why it's so essential to have high performance computing, not only because of modeling, also because then of the hyperparameter, which derive then the best accuracy from these models. A lot of these topics, when you contrast them perhaps a little bit to HPC, which is my other course, it is a bit more automated here. In the cloud computing area, it's for, let's say, users which swipe the credit cards, use a couple of services. So we don't do so much SSH, secure shell, do logins, terminals, programs. So it's a bit on a higher level. That's what I'm going to say, in contrast to HPC, but still more broader in terms of what you can do always for companies, for different sectors in the markets. So we'll also look at customer relationship management systems, enterprise resource planning, how they actually leverage the cloud. All topics you're not familiar with probably, but we will come how that materializes when we are at the different lectures. Good, and then I think the topic of big data mining is often overlapping with machine learning a little bit. So there it's basically a couple of algorithms like clustering or frequent pattern mining that you can quite nicely apply to many applications. Shortly, why I should teach you about this, largely because I'm 18 years now in the field, maybe almost 19, always doing high performance computing and cloud computing since a long, long time. Mostly in a big, large Jülich supercomputing center, which always basically hosted the #1 in the world in terms of the HPC systems. And now we have also quantum facilities, actually, where we do lots of research in. And this brings a lot of knowledge in. Of course, internationally, I'm also here and there in some activities like CERN. Someone heard from CERN, maybe the Large Hadron Collider. I was there for quite a while. And involved with the software developing there for getting the Higgs boson. So this was also an interesting time at that. And of course, this is really big data, right? So in the sense of before the market reaches big data, we in research with LHC and with other actually instruments we had in science, we had that since a long time. So we learned to deal with it. Of course, on another scale than Facebook, this is a different issue, or maybe YouTube today and so on, but still also very interesting to get some knowledge from that. Yeah, in terms of courses, as I said, I teach here since 10 years, roughly, I would say, always different courses. Sometimes it's Thomas Philipp Bruners on statistical data mining in the past, sometimes HPC-B and HPC-A courses, but all were basically around these topics. So the benefit for you in that regard is we could incorporate lots of student feedback over the years and YouTube feedback over the years into that course. So basically there you will see it should be quite, based on what students really like. And basically it fits with a timeline. Just to have a short view, basically where the center is in Germany, just for your information, the Jülich Supercomputing Center, it's basically a really multi-international facility in the middle of the forest because we have also nuclear reactor research. And the Jülich Supercomputing Center is just one small institute from this, serving 6,000 people here on the campus. And yeah, it has lots of topics from all of these different disciplines in HPC, in clouds and big data all over the years, where we basically have also put lots of insights into actually this course from really practical applications. And then the University of Iceland, I think some of you are new here. It's really nice. It's a collaboration since basically 10 years with the Jülich Supercomputing Center. We have now 2 professors, which are basically in both worlds. Gabriel Cavallaro is another one who had actually the course yesterday I talked to you about. And we have around 10 PhDs now jointly, basically going back and forth between these different ones. And the nice things in the University of Iceland is really, it's, let's say, relatively small, but very active, and you have good contacts and a really nice facility with Groska, luckily, you see. That's also where we're very thankful of, at least here in the computer science. And yeah, of course, we do lots of research in remote sensing. We're number 6 in the world, according to some of the lists. So that makes us quite actively in this area. And many of my PhDs, more than the half, I think 6 or so, are working in remote sensing on topics, but always with cloud computing, HPC, and big data intertwined as one of the major application area. We have also some of the PhDs that will just give you a practical lecture, which will be sometimes optional, so not really exam relevant, but still you get a real insight how PhD life is, what topics are there important, and so forth. Just double check the chat here. Sehr gut. Okay. Germanized. Good. Good. From the perspective of the overlaps and all of these different logos, they're incredibly important because this course is not only used for teaching at the university, we teach it there in many of the different activities we have. You see here my research group, and we have a lot of these projects jointly together with the Jülich Supercomputing Center or alone with the University of Iceland. One is a COE race, where this course is basically also actively published on, but many others of those are quite interesting topics, which in one way or another will have always input into this lecture so that you have cutting edge material. UPEX is, for instance, just a project started for a European pilot for exascale computing. What exascale mean, we will talk about. It's just hell a lot of computing on a very, very big scale in the future. However, important for such a course is also the strategy that we have jointly with the Jülich Supercomputing Center and also here in the HPC community. We base on communities. So we have a HPC community in Iceland in different simulation and data labs, as well as Jülich Supercomputing Center, the same strategy. So that we have all, let's say, natural language processing. We have people from acoustics, sound acoustics, up to health, medicine. They all basically are derived and organized in communities using HPC, clouds, and big data in one way. So in other words, this is not a dry topic here, what we do. It's really applied everywhere in all the different sciences. Computational fluid dynamics is just another one. And we will see here and there examples again from my students or from me, so that you see it's really used outside in the field. And this is also what I would like invite you to. The eHPC community is rising. Next week, Wednesday, there will be another event. Some of you know that already. I think you have been there, eHPC community workshop last year, basically, where I would bribe you for 5 credits if you want to come for the exam. It's in the evening, 5 to 7, with wine and cheese, and where you have real experts in the field, right? So they will talk really from companies. Oetna is here, the technology transfer office downstairs, and usually around 50 people. It's downstairs in Groska that we organize. And it would be good that you come there and note your name so that you get the credits afterwards, right? But these are real life events, community events where you have real researchers and also industry people, SMEs, being there and really want to learn about HPC, and you see how they're using it. And if you go to the ehpc.is website, you see these different labs I was alluding to. Obviously, the remote sensing lab is a lab where I'm very actively in, but also Hannes Jonsson is a very great guy in computational chemistry, for instance. So different PIs here at the university that really have big labs there and using HPC, cloud computing, and big data in one way or another. Then when we look a little bit to the idea of one lab that's very open with different members. We see here many different student members. There's basically also PhDs here, but of course we're also open to thesis work, to project work. I think one of the students here, Christopher, where are you? There, yeah, had just a project, for instance, in one of those labs So there's also opportunities. So if you see a lab which interests you from all of these communities that you have seen, and you want to participate, let me know, or let my assistant Katrin know. And then basically we put you in contact, and maybe there's, you know, project work where you can get some credits from, or basically a master's thesis, bachelor project or something like this. So just to say, it's not a closed club. It's actually open, especially for students here at the university, to link and actually also recruit more or less our members in the future of PhDs, and basically of people also handing them, of course, to companies. We have many partners in the European Digital Innovation Hub, for instance. There's Origo is one partner. Borealis Data Centers are a partner in another area, Advani in another. So we have, of course, very good contacts also in the job market here. Good, but so much for these labs. Basically, let's come a little bit more to the other part of the equation, big data, what we do with it. And one of the big applications of big data these days is surely machine learning and deep learning. I would like to focus a little bit on this. Artificial intelligence is a bit more into robotics in a very, very huge topic. So we narrow this a little bit down here in the course of machine learning, where you basically learning from data, so to speak. And the deep learning is still a very special part of machine learning, what you will see when we do also feature learning, what you otherwise in machine learning rather have to incorporate. You also work on feature engineering, feature design. In deep learning, you have the advantage of do some feature learning, basically to automate the process. And deep learning by far now is basically the driver of cloud computing capacity needs, right? So when you want to do really on scale with success on real data sets, you really need cloud computing. The methods that you use is classification. You basically have things like that. You want to have a new data item and you see, should it be a red or green one? You can learn that maybe based on the features of the data. This is something we call classification. Some of you, or the majority of you, know that already. Not everybody said yes, they know machine learning. Clustering is traditionally a bit more into data mining and unsupervised learning, as we would say, where still basically we don't have really groups of them, but the Euclidean distance here, for instance, would let you suggest that might be already two groups, right? They're somehow dots are not in the same, let's say, distribution. And then, of course, regression techniques. We start with this a little bit in linear learning models in one of the next lectures, but it's, let's say, not really the one where machine learning is very successful, rather classification and clustering. And with this, you come to a recipe. What you do in machine learning, you always have these three ingredients. You say that some patterns should exist, right? So random number generators, nothing to learn from. No exact mathematical formula. If you do want to weather forecast something, usually we have there already very good numerical methods that are existing that I teach also in the HPC course, not here. But basically, if there's this mathematical formula, then you implement it and use it, right? There's also no point necessarily of doing much machine learning there. And then, of course, the third is the most important for machine learning. You need to learn from data. That seems to be obvious in this sense. Learning from data requires that you have data sets. And when you now see in our, let's say, satellite images we get from the Sentinels, it's incredible the resolutions we get out. So the big data is really extremely eminent everywhere. In medical devices, we get more signals than ever out of these. So basically, the big data is a big problem, so to speak. As I said, mostly because the technology moves ahead in computing, but is very bad in storage still, right? So we still have a storage hierarchy, which is not really getting the capacity. You can put lots of things into petabytes and tapes, but the tapes are so slow to migrate to an active disk. It takes, let's say, many days for big data. So it's also not really working. And we talk about these challenges when we have big data. But today, this is really a big problem. There are lots of solutions here and there, but not really, let's say, to solve every problem that there is. With this combined, let's say, putting the computing aspect with the overlap, so to speak, on data mining, machine learning, maybe applied statistics, signal processing, there are many fields that apply machine learning. But this has kind of coined a new item called data science. Have you heard from that, maybe, by chance? Data scientist. And you have heard we have a specialization just because of that. And we also want to try to extend it. So Gabriel's course is actually a new course which aims towards this direction, to have more courses in data science in the future. And with Hafstein, another colleague here that just started as an assistant professor, actually, it's also a good opportunity to get really in this field and learning from really experts in the field about different aspects really of data science, of machine learning, deep learning in different areas. This course, of course, focuses on the computing, on the high demands of storage, and a little bit, of course, driven by the applications. And again, here you see this deep learning technique. For people that just know machine learning, you have been probably doing something like having data, and you work heavily a lot on features. At a whole, PhD thesis basically from one of my PhD students that were just focusing on that at that time, 7 years ago, and then creating a machine learning model. And what deep learning essentially these days is doing, it learns the features almost by itself. It's not completely true. You have to do lots of massaging, hyperparameter tuning, finding the right deep learning architecture, but still it's a different approach to learning, right? And this is something we will talk about too. Just for some of you that don't know deep learning, I think the majority have been raising their hand with machine learning. Deep learning, I show you a little bit here. Neural networks, I think some of you have heard about this. It's a very simple learning model called the perceptual learning model, but interesting enough, we'll talk about it, and it's still the major ingredient in deep learning and in neural networks today, just on steroids and many more. What people have thought about combining these perceptrons. So I have not only one single neuron of the human brain, of course we connect it in the human brain, so why not doing that the same way in neural networks? And what the people come up to is a layered neural network, sometimes feed-forward networks, sometimes skip connections. The details is not so important for us, but you see the innovation there is definitely in different layers where you put neurons in. And the interesting thing is now what deep learning was doing is not just getting more and more neurons deeper. So instead, there's innovation in architectural layers. So we treat different layers differently. And one of the examples you see in image recognition is a convolution. You see it's a complete different architecture. There's several aspects we will talk about to filter really features out of the image in different areas. And with this, you have a different approach. In the hand, this is of course still neurons, but you see directly it's not anymore just a wild connection. It's neurons, it's a real architecture that you see a little bit here on the below level, called the AlexNet, which was one of the first really ones. So the message away, and I think I can stop here for a while. The message to take away for deep learning, it's just not more deep learning layers, it's just very smart layers that you use for feature extraction. And based on that, and based on the features you learn, then you do classification, for example. So this is the, let's say, interesting thing where I said 7 years ago with Thomas Philipp Runarsson, this is all a hoax with deep learning. Nowadays, deep learning has really proved it's existing almost everywhere. I have to say in all the applications, the only blueprint that you have is computing, right? So this is the important thing. And the second one, you need data. So this is a slide, a very interesting slide. I've had them actually shown in our German federal parliament as an invited expert once, one of my highest calls, basically where they tasked me of what is now the intersect of HPC clouds, big data, and machine learning and deep learning on one slide for politicians. So, and that's where I come up with, got good feedback on that I'm showing you. So you would say deep learning is always good if you swim in data. If you don't swim in data, don't go for deep learning. If you're just a couple of data sets, stick to other random forest SVMs, traditional learning models, sometimes also called shallow models if it's neural networks. But as soon as you have more data, you see here on the left, the accuracy and the model performance, right? So then you basically, if you swim in data, you have much more capacity. And then the price you pay in the computing time, in the training time, that's where high performance computing and cloud computing kicks in. Now, the bigger the large deep learning network, the more computing has to happen, more mathematical aspects we will talk about. But we keep the mathematical methods to a moderate degree here in the course. It's just a 6-credit course, so don't worry. But still, there is where high performance computing and cloud computing then comes in. And just to let you show how impactful this is SoccerWatch is actually a startup, one of my PhD student who unfortunately quit, but got a very interesting company out called SoccerWatch, who automated basically the soccer watching with a camera and just zooming in, zooming out where the game is happening. 1.7 million Adesso investor grant euros. So basically a totally success. And why that was possible? He was a smart guy, yes, working on neuroscience images, right? Nothing to do with soccer. But a friend came over and said, well, I like soccer and there's this camera, let's put it on. And then they used our machines really with big data, with all of these kind of, basically recordings of the games. And now they have a really niche market where, children play and you can see your child for a small credit card swipe playing. Now they're smart enough to bridge that higher. Actually, now they actually have basketball, volleyball, of course, you can imagine. So it goes up the market stream. And this was just interestingly possible. Firstly, because the deep learning models, again, are really improved and are really useful and impactful in industry and science. But the three key ingredients I wanted to give you as well. So there's big data everywhere today. The hardware with GPUs is just beautiful for deep learning. We will talk about this in this course. Lots of matrix multiplications and things like that. And then the software is all open source. I had students implementing neural networks for me as a thesis in a time where there were no open source tools, no TensorFlow, no PyTorch, no nothing, right? And that was hell a lot of work. And now everything is for free. And so it's a perfect timing, so to speak, if you want to just use and combine all of that and then create, whatever it is. You see this sometimes, I think, for those that are on Facebook with this marketing apps, now flower recognition, right? You have an app for this, fish recognition app for this. So it's the same principle. You just learn a lot of data, you combine the three, and then you have a new company or a new app. From the computing side, I want to mention a little bit the deep series of projects, which basically explore a little bit how exascale and how computing works for different types of computing. We will use these deep machines actively in the course here and there to just do some computing for free, more or less, because it's in our center. You see their modular approach, because today you will see all over the course also people use these clusters and clouds in different fashions from all of these different communities. For example, in earth science, neuroscience, they combine different aspects of these computing elements. And we will talk about this much more when we basically have the first course hours and talk about computing in more generally terms, what's the difference between CPU, GPUs, interconnects, and so forth, and how it then, of course, fuels clouds and data analytics engines. The one concretely in the course we may have a look in, probably also on the extreme scale booster here, will be the DAM of the deep system, but also the ESB of the system, where lots of GPUs are there for free for us to play around with. But of course, we'll also use commercial clouds, MS Azure and AWS and so on in this course. However, I have to say over the last couple of years, they reduce more and more the educational power, in the sense that rather you teach everything on Amazon, right? A full course on it, then you get capacity, but basically the only single services here and they're getting more rare to get. But we're working on this in the moment with getting some credits otherwise bought, so that you don't have to swipe your credit card, right? Which is our goal. As students, you should not do that for a course. Coming basically from the content now a little bit to the modus operandi of the course. I think many of you have probably these as questions, so let's go through this. It is on Canvas, and as far as I can tell now, every time in person. Now, there will be occasions where I basically fly out, I have conferences, I have still, many project meetings. One is actually on Thursday scheduled, unfortunately, so there you have a pre-recording probably happening that I do for you, but otherwise it will be always here and other. Every Tuesday, every Thursday, and on Thursday will be a bit longer. There will be an optional Q&A session on top. So we'll talk basically in both of these Tuesdays and Thursday, but in the third course hour on Thursday, I will be here just, be there. So if you're not coming or have questions for the assignment or so, or for the materials, that would be here. Otherwise, I would also say office hours, let's say longer and basically have lots of other things to discuss. I would recommend to do office hours. Either you ask me, but I will also introduce you to Katrin. She had to go away, my assistant now. Basically, who can then also schedule office hours for me in terms you want to talk. So is there someone who's not on Canvas? Right, it's a quite substantial thing, because I get still very much emails of registering, not registering. Okay, not Canvas yet. Okay, and maybe just stay here with me after the course, we clarify this. Because Canvas will have all the messages, where they have all the information, all the courses is uploaded there. The only difference is, I come to your question in a second, the recordings will be on YouTube. I don't do this Panopto thingy, because we reuse these lectures heavily internationally. You had a question? Yeah.
Well, yeah,
Ah, okay. Yeah, I see. Okay. Right. Of course, yeah, if you have problems with registering in prerequisites, I can also talk about this. So if you, I got some emails about this, no problem with that. Yeah, needless to say, everything is open. The slides are open. The lectures, the practical lectures will be recorded. This is all good. There will be here and there some quizzes. I will talk about this where you maybe should come in person. And of course, I have another course here for you from my postdoc, or now professor, Gabriel Gavallaro, who has this interesting course, 506M. So if you're interested in these topics and a little bit more in application specific to remote sensing, as one example and very good example, I would recommend you also to look into that course. He is a great teacher. I work with him since 7 years. And there's still lots of place in the course. From the modus operandi of grading and assignments, we have basically 3 assignments, which I told you a little bit in the beginning about the blue topics. You can imagine this will come around that. It will be very practical, meaning that it will rather walk through. So there's no big programming exercise here, right? So it's a 6-credit course. You get a script or something which is prepared, or an instruction how to use several cloud services. So this is not a programming course. Matthias Bog and others do software development. There you can learn programming. Here it's rather understanding parallelism, computing needs, clouds, how you use this, and services. It's good to build up groups with this, so 2 to 3. I would really encourage this, because in industry you also basically are always working in a team. So here you can learn it on the university level, really to work with teams together to solve a problem. And so I encourage you really to not stay alone, but do 2 to 3 together. And then please send me the groups once you have found them. We have also the add tool, the add discussion tool in Canvas. It's maybe not obvious. I sent an email soon about this. I already activated this for our course, but we need the structure. This is something where you can also, of course, between the different groups, chat and, discuss a little bit the problems. Then the quizzes are something which is like 4 quizzes, not really a major impact of your time, but I learned with talking with students to give you an incentive to learn the material early, because you will see with 18 lectures, it will pile up a lot at the end. So the quizzes will be giving you a little bit the chance of learning the material already early. You will have small quizzes, which are basically Canvas online also, which tackles mostly these yellow blocks and associated figures in context. Right, and these are also the key to really get a good preparation for the exam, right? So when you learn the yellow blocks in my lectures, that's why I would recommend you to always learn these by heart. These bullets are not always very important in my lectures, but the yellow point should be learned. If you have these and then the couple of graphics in context, then basically your exam will be not a problem. And of course, I invite my PhD students really as practical people inside these lectures. So every now and then you will see also practical lectures from Gabriel, practical lectures from Rocco, several of my PhD students talking about several different topics. But many of these lectures are partly also optional or interesting events where I said there's this incentive next week, Wednesday evening, right, for getting 5 credits. It's much more important than 5 or 6 lectures from everyone. If you do a real community event in the community next week, Wednesday, you will see that has so much more impact. And so forth, we really would encourage you to come there. And this will come again in October. We'll do another workshop and so on. Right, the ad platform I already said. So there will be, questions, answers. Basically, my assistant will look over that these days because I got more and more workload in the last year. So I think it's good to have someone who is helping us a little bit if there are questions towards me. And I will send an email about this. Probably other courses use ad as well, right? There's probably someone from you who have used ad or so in other courses. Exactly. It's a common tool here. And I think the look and feel is quite nicely in this regard. In terms of literature, it's really difficult. Cloud's evolving so quickly that assignments I do last year are not anymore working this year because the cloud advanced. So here, the point is really think about associated literature to some degree for these books, which I found is interesting, but don't really book them necessarily and buy them or whatever, rent them. I would say many of them are in the web, and you see in all my literatures, I have lots of bibliography, 3 to 4 pages, just links to websites where I have much more cutting edge information, much more newer information than any book provides, because they evolve so quickly. I gave the example of Amazon Educate, basically, which transformed to the academy suddenly in the middle of nowhere. So of course it's commercial setups, they want to earn money, so they don't stay so context. Hence, rather use the bibliography which is there in the kind of part. Finally, just a short advertiser here. Next sprint is again the HPC course, had lots of overlaps, which you will learn throughout the course if you have interest, and maybe have a look on the webpage from Canvas. And yeah, as a motivation, maybe a little bit longer, just a short video for 2 minutes to get you motivated to come back, hopefully, to the second part of the prologue, where we talk then about the content step by step.
It all begins from a single origin, a unique point in space and time. This is the spark of innovation that fuels your most amazing breakthroughs. It's a passion for discovery that unveiled the genesis of all that exists in the universe. Today, the power of AI helps computers achieve superhuman capabilities in image recognition, and lets scientists save our most precious resources by analyzing in 1 month what used to take 10 years.
是谁发明了机械计算机？
Everyday devices translate even the most complex languages from voice into text, and images into words.
Xavier is now present.
Helping the visually impaired recognize an old friend, or letting a blind woman read to her child for the first time. Autonomous vehicles give us the freedom to reimagine our city streets and travel where there are no streets at all to help the lost find their way home. We see robots teach themselves to perform simple tasks. We even watch in awe as they take their first steps. And today, a 2,500-year-old game meets its match as a computer competes with one of the greatest human champions of all time and wins. This is the collective imagination, fueled by forward-looking technologies and the beginning of your most amazing discoveries yet to come.
Hey, no, I'm actually not paid by NVIDIA, for the record. We break here for 10 minutes and come back for the second part. Thank you.